is, dear students, if you are able to understand the idea of limits thoroughly, then you will be able to read any real analysis book of your work, right? So what I want to say is, the idea of limit, concept of the limit is clear to you, then you will be very confident with reading any textbook of your own. So try to understand carefully. So my main aim is to convince the second year and the third year BSc students, and also it will be useful for MSc students. So is it clear? So dear students, what we are going to discuss today is, we are going to discuss some very simple idea called the limit of functions, and then we are going to discuss about continuity of functions. If time permits, we will discuss about uniform continuity also, right? So try to understand the definition first. The definitions are important. You should not cross the definition just like that. First, try to understand the definition, justify the definition. Then we take some simple examples to understand the definition. Then it will be clear. You don't need to memorize the proofs. You will be able, once the definition is clear, you can write the proofs your own. That's what I want to say. Right? So shall we start? Are you ready? Yes. Some of the BSc students can respond to my questions. Okay. So I will be slow enough. So try. You can stop me whenever you have some doubt. Limit of the function. For many students in the undergraduate level, the epsilon delta definition of limit they may feel it little tough to understand. Now, my aim is to make them understand it clearly. So I will start with some simple example. Because, dear students, for a moment you assume that you have never seen this limit symbol. Right? For a moment, we will try to define it. So consider the function f from R to R. I am starting with simple functions. F from R to R, given by the formula f of x. This is equal to 2x. So the function is from R to R. The domain is R. Codomain is R again. R denotes the set of all real numbers. The function is given by the formula f of x equal to 2x. Now, if I ask you, what is the limit of this particular function f of x when x goes to 2? What will be the answer? You will be able to tell immediately. What's the answer? Anyone of you, any BSc students? Are you able to hear me? Anyone of the BSc student can respond to my question. Anyone from the students? What is the limit of it? Yes, what's the answer? Anyone from student side? BSc students? Are you able to hear?
Yes, Pillai.
4, right?
Yes.
Yes. Answer is 4 because you have already some knowledge from your higher secondary mathematics. You will be able to answer easily that it is 4. That means we have some intuitive idea about what is the limit. You will be able to tell easily that the answer is 4. Now the question is, what do you mean by this? What do you mean by writing like this? Limit of this function f of x is 4 when x goes to 2. What's the meaning? So when you say answer is 4, what was running in your mind? For example, if someone asks you, no, substituting. So maybe by substituting the code, but the limit is different from substituting. That's what I want to explain today. What's the meaning? What's the intuitive meaning? What's the What is your intuitive understanding about this particular limit? Roughly, by writing this particular limit, that is by the limit of f of x is 4 when exposed to 2, what we mean is the value of f of x, the value of the function f comes arbitrarily close to, comes very close to, or arbitrarily close to, comes very close to, or arbitrarily close to 4 when x is close enough to 2. This is what the intuitive understanding behind this limit. Really, this is the way we understand in our higher secondary. Is it okay? That is, the value of f of x, the value of the function f comes, or f of x comes arbitrarily close to 4, or comes very close to 4. Not always. When x is close enough to 2. This is the way we understand in our higher secondary. Now, we have to make the things precise only because if you have no numerical, you may not be able to prove theorems, right? So now we have to make the things precise. Dear students, try to understand. Now, here you have to justify. What do you mean by very close? What do you mean by very close? F of x comes very close to 4, or f of x comes arbitrarily close to 4. So you have to make these two terminologies precise. What do you mean by saying that f of x comes very close to 4 or arbitrarily close to 4? These two terminologies you have to make it precise. What do you mean by very close? Or what do you mean by arbitrarily close? Arbitrarily close means how close it is. This will be the natural question, right? Are you able to understand?
Yes, sir.
Yes. So, to understand, to arrive at the epsilon delta definition of limit, you can understand the following discussion as a conversation between the teacher and the student. For example, dear student, as I said earlier, for the moment you think that you are learning the limit for the very first time, right? So, for example, the teacher is coming and writing that the limit of this particular function, limit of f of x, the limit of this function f of x is 4. The same function f of x is given by the formula 2x. When x goes to 2 is 4. This is, the teacher is saying this statement, therefore the teacher has to defend his statement. Now, obviously the student will ask, sir, what do you mean by this? What do you mean by this? Or what do you mean by writing this? So, what will be the teacher's reply? Teacher will say the same thing. By writing this limit of f of x is equal to 4 when x goes to 2, I mean the value of f of x. The value of f of x, I mean the value of f of x is arbitrarily close to or very close to, arbitrarily close to 4, not always. When x is close enough to 2. That's all. I am starting my conversation here. That's all. Right? This is the way we explain. That is, when we are trying to explain this particular limit to some of our friends, this is the way we explain. The value of f of x is very close to 4 when x is close enough to 2. That is, f of x comes closer and closer to 4 when x is coming closer and closer to 2. This is the way we used to explain to our friends. The same thing. Now we are going to make it precise. And the teacher is saying that the meaning of this is the following. That is, f of x comes arbitrarily close to 4 when x is close enough to 2. Immediately the next question by the student will be the following. Sir, what do you mean by this term arbitrarily close? Or arbitrarily close means how close it is. So this is what the meaning. What do you mean by What do you mean by arbitrarily close? What do you mean by arbitrarily close? Arbitrarily close means how close it is. Arbitrarily close means how close it is. Obviously this will be the natural question. Now the teacher will be defending himself as follows. Teacher, the student is asking, sir, what do you mean by arbitrarily close? Arbitrarily close means how close it is. The teacher will be defending himself as follows. How close you want to make it? You tell me that close I will be able to make it. That's all. How close you want to make it? How close you want to make it? You tell me that close I will be able to make it. That's all. That is, now the student will be start challenging the teacher as follows. That is, sir, can you? Dear students, are you able to read what I am writing on the screen?
Yes, sir.
So, now the student will be start challenging the teacher. Sir, can you make the value of f of x to be, possibly he may come with a small number, to be 0.01 close to 4, because the teacher first told that by writing this limit, what he means is the value of f of x comes arbitrarily close to 4 when x is close enough to 2. Now he is asking, sir, can you make the value of f of x to be this much close to 4? This is what the student is challenging the teacher. Now, how the teacher will defend himself? Answer is yes. In the back of the mind, the teacher will have, because we will interpret. So the student is asking, sir, can you make the value of f of x to be this much close to 4? In symbols, his question can be written in this way. That is, can you make the value of f of x to be this much close to 4? This is what to mean. That is, I have rewritten the question asked by the student. Is it okay? Is it clear to you so far?
Okay, sir.
Yes. Now look at the answer. Teacher is saying that f of x comes arbitrarily close to 4 when x is close enough to 2. That is, now how the teacher will defend himself is as follows. That is, the student is asking the teacher to control the distance f of x from 4. So what the teacher will do is, he will estimate the distance of f of x from 4 in terms of the distance of x from 2, because he is saying that f of x comes arbitrarily close to 4 when x is close enough to 2. Therefore, what the teacher will do is, he calculate f of x is given by the formula 2x, and it is minus 4. It is equal to 2 times mod x minus 2. So the teacher will have this particular estimate in his mind. So look at this formula. Look at this estimate. This estimate says that the distance of f of x from 4, this is equal to 2 times the distance of x from 2. Now, having this particular estimate in his mind, the teacher will be able to answer the student very easily. Now it is easy. What the student is asking? The student is asking, can you make the distance of f of x from 4 to be less than this number? If we expect this particular number, this is equal to this 2 times mod x minus 2. That is, if we expect 2 times mod x minus 2 to be less than 0.01, then obviously x minus 2 has to be less than half of this. Therefore, the teacher will answer it as follows. Yes, the teacher's reply is the following. What the teacher will be answering is yes, if x is half of this number, 0.005 close to 2, that is, if x is this much close to 2, then f of x will be 0.01 close to 4. This will be teacher's reply. That is, in symbols, what the teacher is saying is, whenever the distance of x from 2 is less than this particular number 0.005, Then we have the distance of f of x from 4. This will be less than 0.01. Right? This is what the teachers will be. Right? Understand? First, the student is coming with a number. The student is coming with a number, namely 0.01, and he challenges the teacher. Sir, can you make the value of f of x to be this much close to 4? Now the teacher defends himself by giving him a number back and saying that if the distance of x, this is the number given by the student, and now the teacher is giving him back another number, saying that if the distance of x from 2 is less than this number, then the distance of f of x from 4 will be less than your number. That's what it is, right? Now the innocent student, because the student may not be knowing this particular estimate. Only the teacher is knowing this particular estimate for modulus of f of x minus 4 in terms of x minus 2. The student may not be knowing this particular estimate. Therefore, the innocent student may be challenging the teacher again, possibly coming with a smaller number. For example, the student may come with another smaller number. He may be challenging the teacher again, as far as so this time the teacher is successful. Now again the student is challenging the teacher as follows: Sir, can you make f of x to be, maybe earlier he may think that earlier he came with such a small number, such as now some 0.01. The teacher could succeed. So this time possibly the innocent student can come with still smaller number, 0.00001 close to 4. This time he is challenging the teacher again by coming with a smaller number like this. That is in symbols. In symbols, if you write, can you make in symbol? The student is asking, sir, can you make the distance of f of x from 4 to b less than this number, 4 zeros 1. This is what the question. Now again the teacher's role is easy now, because already he is having this particular estimate in his mind. Just what he will do is, he will divide the number given by the student by the number 2, then he will give another number answering in the same style. So now the teacher's reply will be the following. Now the teacher will tell the following, that is, yes, again, yes, if x is half of this particular number, the teacher will divide this particular number because he knows this particular estimate for the function f of x equal to 2x. 0.45 zeros, then 5, close to 2, then your f of x will be 0.4 zeros, 1 close to 4. That is, this time again, remember that the student is again in the second step. The student is coming with another smaller number and challenging the teacher. Sir, can you make the value of f of x to be this much close to 4? Yes. The teacher is answering yes. If x is within this distance from 2, then f of x will be within this distance from 4. That's what the meaning. In symbols, what the teacher is saying is, whenever the distance of x from 2 is less than 0.5 zeros, 1, 2, 3, 4, 5 zeros, then your f of x will be within your distance, the number given by you, 4 zeros, 1. This is what the meaning. So in this way, the innocent student will be every time coming with some number, possibly smaller and smaller number, and he will be challenging the teacher. Sir, can you make the value of f of x to be this much close to 4? Again, the teacher will be giving him back another number, saying that if the distance of x from 2 is less than my number, then the distance of f of x from 4 will be less than your number. Are you getting my point? This is what is happening. In brief, what is happening in this conversation is, the student is coming with a number, positive real number, and he is asking the teacher, sir, can you make the value of f of x to be value of f of x to be can you make the distance of f of x from 4 to be less than my number? That's what the question of the student. Now the teacher's reply is, teacher is giving him back another number, saying that whenever the distance of x from 2 is less than my number, then the distance of f of x from 4 will be less than your number. This is what happened. So in this way the conversation will be keep on going on. So in summary, so in brief, what is happening is, every time the student is coming with coming with a positive real number, right, and asking, sir, can you make the value of f of x from 4 to be less than epsilon? This is what I mean. Every time the student is coming with a positive real number and asking the teacher, sir, can you make the value of f of x to be epsilon close to 4? The teacher, what the teacher is answering is yes. He gives him back another real number that we denote it as delta, and answering that whenever, saying that modulus of f of x minus 4, the distance of f of x from 4 will be less than epsilon whenever the distance of x from 2 is less than my delta. This is what happening. In brief, this is what the conversation happening in this epsilon delta game. Is it clear to you so far? Yes, sir. That is, the teacher is able to defend his statement successfully means, for every epsilon greater than 0 given by the student, the teacher is able to give him back a delta greater than 0 satisfying this particular condition. That's what the meaning. That is, first try to understand who is making the statement. The teacher is making the statement, therefore the teacher has to defend. That's what is happening here. Every time the student is challenging the teacher coming with a positive real number epsilon, and the teacher is able to defend himself by giving him back a positive real number delta satisfying this particular condition. That's what I mean. So this is what we. So the teacher is able to defend himself successfully means, for every epsilon greater than 0 given by the student, the teacher is able to give him back a delta satisfying this particular condition. This is what we write as a definition. Definition we take. Once if you have a definition, then we will be able to use it instead. Suppose f is a function from some interval, I stands for some interval to R, and say A is a particular point in I. Then the limit of this particular f of x is not 2x. Just now it is a general function, general situation. Now the limit of the function f of x is the number L when x goes to A. Means what? Means for every epsilon greater than 0 given by the student. So intuitive meaning is the value of f of x. When I write the limit of the function f of x is the number L when x goes to A, what is the meaning is, intuitive meaning is the value of f of x comes arbitrarily close to L when x is sufficiently close to A. This is what the meaning. That's what written as a rigorous definition here. That is, for every epsilon greater than 0 given by the student, there exists a delta greater than 0. That is, the teacher is able to give him back by the teacher satisfying the following conditions, such that whenever the distance of x from A is less than delta, we have that the distance of f of x from L is less than epsilon. This is what. Is it okay so far?
Okay, sir.
Okay. Now this is what in one line we can write. That is, for maybe as in the textbook we can write in this way. That is, for every epsilon greater than 0, there exists a delta greater than 0 such that modulus of f of x minus A, this is less than epsilon, L. This is less than epsilon whenever the distance of x from A is less than delta. I am making a small mistake here, I will correct it. So in terms of quantifiers, quantifiers means, for example, is for every there exists, they are examples of quantifiers. Instead of writing this in words like this, we can write briefly as follows. For every epsilon greater than 0, we have the following. What is that? There exists a delta greater than 0 satisfying the following condition. That is, for every x whose distance from A is less than delta, we have the following. What we have? Modulus of f of x, that the distance of f of x from L is less than epsilon. This is one, like that's what the name. 1, 2. Yes. You read in this way. For every epsilon greater than 0 given by the student, the teacher is able to give him back a delta greater than 0 satisfying the following condition. That is what? If you take any x whose distance from A is less than delta, the distance of f of x from L will be less than epsilon. This is what we mean. Is it clear?
Yes, sir.
You understand this particular line as follows. Whenever an open bracket is getting opened, in your mind you read as, we have the following. For example, I am reading this line once again. For every epsilon greater than 0, we have the following. What we have? There exists a delta greater than 0, for which we have the following. What we have? For every x whose distance from A is less than delta, we have the following. What we have? The distance of f of x from L is less than epsilon. That's what I am repeating. Whenever a bracket is getting open, in your mind you read that we have the following. That's what I mean. So this delta is changing with your epsilon. That is clear from the conversation, right? If the student is coming with an epsilon and depend upon the student's epsilon, the teacher is giving him back a delta. So, for example, if the student is coming with a very small number, then again the teacher has to divide this by 2, then he has to give him back another number. Delta. Is it okay? The choice of delta varies with epsilon. That is, if you come with, for example, assume that you are the student, I am the teacher. If you come with an epsilon, corresponding to your epsilon, I will be able to give you back a delta satisfying this particular condition. And if you change your epsilon, automatically I have to change my delta. Is it okay? Is it okay so far? Yes. This. Students who are already familiar with this epsilon delta definition, can you tell me? I have made a mistake here. Can you correct me? I have made a mistake in this definition. I have written the limit definition only. The limit of f of x is L where x goes to A. Means the following. I have made a small mistake here. Can you correct me if you are already familiar with the epsilon delta definition? Students, anyone? MSc students at least? I have written the definition of limit. There is a mistake I made here. Can you correct me? Okay, then I will ask you a question. From there I will. Now you consider this function f from, I am using the same symbol f for all functions, but depend upon the example the formula changes. F from R to R given by the formula f of x, this is equal to 3 if x is different from 2 and it is 0 maybe 1 if x is equal to 2. That is, look at the function. This is 2. How the function is defined? whenever x is different from 2, the function takes the value 3. So and then at x equal to 2, the function takes the value 1. So the graph of the function, the graph of f consists of 3 parts, 3 components. This array and this particular array and this dot. So the graph of f contains 3 parts. Yes. Now my question is, what is the limit of this particular function f of x when x goes to 2? Anyone? What's the answer? You have to tell me. What's the answer? Yes, if you tell something wrong, there is nothing wrong, we will correct it. Just I want your response. What's the answer?
1, sir.
Answer is?
1.
1, yes. Any other answer?
4. Near to 1, sir. Near to 1, sir.
4. No, the function is given by this particular formula. F of x is 3 whenever x is different from 2 and 1 is equal to 2. Any other answer? Yes, one student go to that, the answer is 1. Any other answer?
3, sir.
3. Any other answer? Any other answer? Usually when I ask this particular question to students, usually these 3 answers used to come. 1, 3 and I will get one more. Usually I used to get one more answer. Does not exist. These 3 answers I used to get normally. Now you will see what is the correct answer. That is, dear students, try to understand. This is the one particular point. The limit, when I say the limit of a function f of x when x goes to a, this is not actually taking the value of f at a, because to denote the value of f at a, we have such a nice symbol. Then why to write like this? Are you getting my point? So this is different from this. That's what I wanted to. The idea of limit of a function when exposed to a particular point a. This is different from the value of f of a. This may be equal to f of a sometimes. That is a different issue. But the idea of limit is not just to take the value of the function at the point a. That is different. When we are talking about, try to understand. When we are talking about the limit of the function f of x when x goes to a, what's the meaning is we are trying to understand what is happening to the value of f of x when x is coming arbitrarily close to a, but x is different from a. Remember that. That is the general situation. Suppose this is the interval a comma b. Say this is n points again about it. Say this is a. Limit, when you are trying to understand what is the limit of f of x when x goes to a, what you are trying to understand is, assume that you are walking along the x-axis towards a. You can walk from either left or right, that doesn't matter. What's the condition is, you can come any close to 4. In Tamil, close you are allowed to come any close to 4, but you are not allowed to reach a. That is usually, that is the reason. Usually for the beginners, whenever we fix the limits, we use the right x is different from a below. So it is understood. X goes to a means x can be allowed to come any close to a. X can, that is, assume that you are walking along the x-axis towards a, you are allowed to come any close to a, but you are not allowed to reach that particular point. That is, we are not interested in knowing what is the value of what is happening to f at a. We are interested in knowing what is happening to the values of f of x when x is coming arbitrarily close to a. This is what I mean. Are you getting my point? Therefore, the first point you have to remember when we discuss about the limit. The first point you have to remember when you discuss about the limit of a function when it goes to a is you forget about the point a and the number f of it. That is, remember that x is different from a. That's what the mean. Is it okay? That is, we are not interested in knowing what is happening to f at a. We are interested in knowing what is happening to the values of f when the values of x are coming closer and closer to a. This is what we are interested in. Is it okay?
Okay, sir.
This is what the mean. So, I am not interested in what is happening at that particular point. Therefore, what should I do is, the first point I have to remember is forget in the definition. Forget about the point a and f of a. That is, this is a, x goes to a means it can come very close to a, but it is different from a. That's what I want. So here x is, so in the beginning usually we will not write in the textbooks. For the beginner you can write in this way: x is different from a. To say x is different from a, we put it is strictly greater than 0. That's what the point. So here it is. Is it okay now?
Okay, sir.
Okay, sir.
Okay. So this is what the name. So now come back to the general definition. For every epsilon greater than 0, there exists a delta greater than 0 such that for every x whose distance from a is less than delta, except possibly the point a, we have that the distance of f of x from L is less than epsilon. Try to understand. We can draw two kinds of picture to understand this. First, in the real line, as in the f is a function from R to R given by the formula f here. A is sitting here, L is sitting here. Look at this definition. For every epsilon greater than 0 given by the student, the teacher is able to give you back a delta greater than 0 satisfying this particular condition. So what's the meaning of this? That is for every epsilon, I am rewriting this in terms of intervals. For every epsilon greater than 0, there exists a delta greater than 0 such that whenever the distance of x from a is less than delta, it means whenever x belongs to the interval a minus delta comma a plus delta, but x is different from a. Therefore, I will remove that particular single point from this interval. For every point, for every x on this interval, we have that the distance of f of x, that is f of x will become a member of this interval. The distance of f of x from L is less than epsilon. It means f of x belongs to the interval L minus epsilon comma L plus epsilon. Is it okay?
Okay, sir.
Or I will write in this way because too many brackets you may confuse. For such that x belong to the interval, open interval a minus delta comma a plus delta minus the single point a, implies that the image f of x will belong to the interval L minus epsilon comma L plus epsilon. Is it okay? This is what I am writing here. That is, in terms of inequalities, I am writing in terms of intervals. For every point x belongs to this deleted interval. Deleted means the center is deleted. For every point x in the deleted interval, f of x will belong to this epsilon interval. Is it okay? Now, we will be able to, we can draw pictures to understand this because the picture will help you to remember the definition easily. We can remember this definition as follows: the limit of the function f of x is L when x goes to a means we have to start from the polynomial, that is given. That is given means for every, you can read as given or for every. Given any epsilon interval around L, that is epsilon interval around L minus epsilon comma L plus epsilon. That is, if the student comes with any epsilon interval around L, the teacher is able to give him back. That means there exists means the teacher is able to give him back a delta interval, namely A minus delta comma A plus delta, such that every point in this delta interval around A except possibly the center A, every point on this interval will be mapped to, every point in this interval will be mapped to this interval. That's what. For every point here, the image will be here. That's what I mean. That is, the student has the freedom to come with any small epsilon. Any small epsilon. Epsilon can be any small. When the epsilon is small, it keep on decreasing. The size of this interval will be keep on reducing. That doesn't matter. Whatever may be the epsilon you come with, that doesn't matter. Depend upon your epsilon, I will be able to give you back a delta interval around A, such that for every point here except possibly A, the image will be inside your interval. Is it okay? This is what I mean. Is it okay?
Okay, sir.
That is, we can control the distance between f of x and L by controlling the distance of x from A. This is what I mean. That is, we are able to control the distance of f of x from L by controlling the distance of x from A. This is what I mean. This is what you are. That's a reason for this in here. Every problem, whenever we are interested in doing a limit, this is what we want to control this by controlling this. Therefore, what we will do is we will estimate this in terms of this. That's what. In analysis, this is what we will do. By the purpose of inequalities is the following. We will be interested in controlling some quantities. So the idea is try to write the quantities which we want to control in terms of the quantities which we can control. That's what the idea. So we estimate the distance of f of x from L, because the formula for f of x will be given to you in any problem. In terms of, these are the two lines you have to remember, in terms of the distance of x from E. This is what I mean. That is, writing several times to make it clear. Limit of f of x is L, x goes to E. So, what we are trying to do here is, the limit of f of x is L when x goes to A means that we can control the distance between f of x and L by controlling the distance of x from E. So, the distance between f of x and L can be made any small by taking x close enough to E. This is what I mean. Another picture to understand this is the following. One way of drawing a picture is this, domain and codomain. Another picture is using a graph. That is, say, A is here, L is here. The limit of over that, we have to estimate an important point. We have to estimate this in terms of this when x is different from E. This is what. Because we are talking about limit, you remember that x is different from E. Here, and it's very in the definition. A is here, and assume that this is the domain, this is a copy of the real line domain, this is the codomain. The limit of f of x is L when x goes to A. This means, I am repeating the definition, restating. If you come with any epsilon interval, that is, if the student is coming with any epsilon interval around L minus epsilon comma L plus epsilon, I will be able to give you back a delta interval around A minus delta comma A plus delta, such that every point on this delta interval, that is, this is given by the student, and this is there exists, that is given to the student back by the teacher. There exists a delta greater than 0, such that for every point here in this interval, except possibly the center A, image will be inside this interval. This is what the meaning. That is, if we come with any epsilon interval around the L, we will be able to find a delta interval around A such that every point of this delta interval except possibly A will be inside this. That's what the meaning. See, try to understand this. You have the freedom to choose this epsilon to be any small. Whatever may be the epsilon, there corresponds a delta. It means this one. We are able to control the distance of f of x from L by controlling the distance of x from E. This is what the meaning. Is it okay, clear? Is it clear? Shall I go ahead? Now we will come back. Now we have the rigorous definition. Definition. F is some function from some interval I to R, and A is any particular point in I, and we say that the limit. We say that the limit of the function f of x when x goes to A is the real number L if the following happens. For every epsilon greater than 0, there exists a delta greater than 0 such that for every x belong to the interval A minus delta comma A plus delta minus singleton A, we put for every. This implies f of x belong to L minus epsilon comma L plus epsilon. This is what I mean. That is same as saying that for every epsilon greater than 0, there exists a delta greater than 0 such that for every point on this interval, delimited interval, the image is here. It means that f image of this interval A minus delta comma A plus delta minus singleton A. F image of this particular interval, delimited interval, that is contained in L minus epsilon comma L plus epsilon. This is what exactly explained through the picture. This is what I explained here. If you come with any epsilon interval around here, we will be able to find a delta interval around A such that the image of this interval is inside this. That's what I. Now we have the definition. Now we will prove one or two problems by using this definition. Example, now come back to the original problem. Consider the function f from R to R given by the formula f of x. This is equal to 2x. Now prove that the limit of maybe I will start with a simple problem, then we will go on 0, 3. 0, 3 to R, limit of this function f of x when x goes to 2 is 4. Do you agree the answer is 4? The same example. Do you agree? Able to hear me?
Yes, sir.
So now we have the definition. We have to prove this limit by using the definition, right? So the first line of the proof, is start with an edge. Start with an epsilon greater than 0. Why we have to start with an epsilon? That's what the definition. That is, the limit is 4 means the distance between f of x and 4 can be made any small. That means if we come with any epsilon greater than 0, we can make this to be the distance between f of x and 4 to be less than epsilon. When? By taking the distance of x from 2 small enough. That's what we mean. Dear students, one more point I want to tell you that the epsilon in this definition, because whenever we ask the student what is this epsilon, they used to tell very small number, very very small positive real number. There is nothing like that. Epsilon can be any positive real number. For example, in this conversation, look at here. Epsilon can be any positive real number. It need not be very small number or very little number. There is nothing like that. Epsilon can be any positive real number. For example, in this conversation between the student and the teacher, for example, if the student is coming with some very big number like 1000, The teacher no need to think anything. Without thinking much, he will be able to give his delta to be 1. Right? When the student is coming with some very small number like 0.01 or 0.001, the teacher has to divide his number by 2 and he has to reply carefully. Are you getting my point? That is, if you come with a very big epsilon, then my job of giving you back a delta is very simple. Is it okay? Are you able to understand?
Yes, sir.
Yes, the epsilon need not be very small. If you come with a very big epsilon, then my job of giving you back a delta is going to be very simple. That's what I want to say. That's all. When you come with a very small epsilon, I have to work it out with you. That's all. I have to think it. So epsilon is any positive real number. Start with an epsilon. Our aim is to find a delta, but I do not write everything. Therefore, what you have to do is to estimate this time. If these two lines are clear to you, you will be able to solve any problem. We have to estimate f of the distance between f of x and 4 in terms of the distance of x from 2. We have to be careful. One more line we have to write. When x is different from 2, remember this, because this is going to be helpful in understanding. That is, whenever x is different from 2 and x is a point in the domain, you have to estimate f of x minus 4 in terms of this.